Hi, my name is Marty Bacall. Welcome to today's webinar, How Your Peers Are Leveraging Legacy Systems for Innovation. So first, some housekeeping items. The on-demand recording of this webinar will be distributed to you within 24 hours. Questions can be submitted anytime by clicking on the Q&A icon at the bottom of the webinar portal. And please give us feedback. Tweet to us at #OpenLegacy. And now our agenda. We're unlocking legacy systems to enable speed and innovation. And then we're going to talk about legacy modernization in the world of API, DevOps, and microservices. And then we talk about leveraging legacy systems with microservices. And on to our speakers. Our first speaker is Craig Beattie, Celent Senior Analyst. He has extensive experience in IT architecture strategy and legacy modernization. Next, you hear from Zeev Avidan, Chief Product Officer for OpenLegacy. Zeev works on the front lines, closing the gaps between legacy systems and digital innovations for financial institutions. Now on to Craig.
Hi everyone, and welcome to the webinar. Thank you, Marty, for the introduction there, and thank you to OpenLegacy as well for the opportunity to speak here. Let me just adjust the slides a little bit. Here we go. So I'm going to first talk a little bit around digital transformation opportunities in legacy systems. I'm going to get into microservices, APIs, and DevOps. So hopefully that's what you're expecting. And then talk a little bit around some of the what I see as the path forward for enabling legacy modernization. So let's go on with the slides. For those who are dialing in, there's a few slides, but I'll try and signpost it. So hopefully you can hear what I'm saying and follow along. But the recording will go out to you, so you can always see it with the video afterwards if you're just dialing in. So, the rise of the channel silos. As Marty said, I'm an architect by background, and so we often talk about silos and that sort of thing. Life was much simpler a long time ago, both for insurers, for banks, for all financial institutions. There was typically a channel. There was one route for getting things into the organization, and a set of systems that enabled that. Then as we started to see new channels coming in, we added another stack of systems to help that. Maybe contact center. There was a typical one as everyone went to the phone. And then as we all went online, went on the web, the big 2000, we saw another stack of technology. And now as channels are radically increasing in number and variety, we're starting to add mobile devices, we're adding chat icons and all of these sorts of things. It's really not a scalable solution to just keep adding an entire stack of technology each time we keep adding a new channel or a new route to market. So we needed something simpler. So SOA helped, but didn't fix the problems. So what we saw was a route to decoupling back-end systems, systems of record, if you like, or product systems in the back-end from the channel systems. So we tried to say, well, actually, we've got some systems of record, we've got some back-end systems that do offer our products, but actually they're different from the systems at the front, the things that deal with branches, the things that deal with high street stores, the things that deal with our contact centers, the web channel, the mobile channel, the new chat channels, and all of that. So we tried to decouple those, but actually it didn't quite work. The SOA integration layers were often quite thick. The RPC style, the remote procedure call style of those integrations, tightly coupled to the product systems. We often saw a lack of reuse across the integration layers, depending on different systems, but it was a step in the right direction. It moved us forward. Let's put it that way. So what we're seeing now is something when displayed logically looks kind of similar actually. We still have a set of background systems, product systems in the back. We now have an API that allows us to access those product systems. And we still have these systems of engagement, these systems at the front that are supporting the many different channels that we offer. What we're increasingly seeing across banking, across insurance, across all financial services at the moment, particularly with the rise of fintech and with the rise of insurtech, is the need to start to partner and offer third-party products. So taking offerings and systems from other people, consuming their APIs, if you like, but also distributing our products through other systems as well. So looking at third-party channels. This used to be something that maybe was a white label system or a white label offering or something like that. Maybe we're now selling bank accounts through supermarkets and that sort of thing, or selling insurance directly through a travel agent. But this is becoming the new way of doing financial services, as being part of a wider ecosystem, being a participant in that, and getting the right things out there for our customers and also our partners. Now, this is an interesting adaptation, if you like, but it's not significantly different from the previous one. What I think is very interesting around APIs as opposed to SOA as it was 8 years ago is the focus on ease of adoption, the focus on making sure that these things are easy to implement. And there was a significant amount of discussion between myself and Zeev around the idea of the developer experience and how we construct these things. But it doesn't always look like this when it's fully implemented. This is a logical view. So maybe we can take a look at an implementation. So we're going to move into how leading banks and insurance organizations are using a combination of microservices, DevOps, and APIs. So let's take an example here. So this is a more concrete example, still fairly logical, but it gives you an example from a model bank winner a couple of years ago. We can still see the same layers, right? So we've got the internal channel systems, the third-party channel systems. The API here is not represented as a layer, but rather a perimeter around some of the product systems. And then we have the third-party product systems and the internal product systems. So it's still very similar to the diagram we saw earlier on, but it's expressed a little differently. And we can see here in terms of number one, the presentation layer, we see apps, web, and other. I like the idea of other channels. It's a good catch-all. But we also see partners in there. So that's a third-party channel system. It's the concrete example there of how we're starting to get financial institutions, in this case a bank, are starting to surface their capabilities, their products, their offerings into third-party environments. And then at the back here, we see internal product systems, so the core systems that this bank uses to offer their particular products. But actually, they've got some third-party systems that they're starting to bring in and merge with their products so that they can offer a more complete offering. So, and this is an example. So this is a nice concrete example. It gives a good demonstration of how these things might surface. But this is a pattern that we're seeing repeated across all financial services. As the in some cases, this is something that one organization offers. In some cases, we're seeing fintech, where they are the third party, and they're looking at how can we surface an API that makes it easier for other participants in the financial services industry to offer our product and get it out there. So it's a very interesting evolution of how organizations are moving together, and led to the rise of the new word coopetition as well amongst financial services. So transforming legacy systems. So it's all very well describing how this all fits together, and we've seen an evolution from these silos, and then the attempt to break the silos with kind of a version 1 of the service-oriented architecture. And then we've arrived at this idea of well, actually, let's have product systems that surface capabilities and offerings through an API, and then they can be consumed by we can call it channel systems or systems of engagement, and then that reaches out to either a customer or another company. And actually, not all of those services that we're offering might be ours. Maybe we'll consume others. And actually, not all of the channels that are going out might be ours. Some of those might be others as well. But actually, in a world where we've got legacy systems, this seems like a nirvana situation. Legacy systems historically slowed us down. So how does all of this transform or enable transforming of legacy systems? So one thing I wanted to broach with you all on this webinar is that the opportunity around legacy systems is larger than the legacy systems themselves, actually. So technologists and developers and architects often talk about a phrase, technical debt. And the idea here is that by making certain technical decisions, we increase the amount of work that we need to do in the future. We create a debt, if you like, an effort that we're storing up for somebody else to fix in the future. Now, legacy systems offer a certain amount of technical debt, right? They're a system that does some work, but actually replacing them is a significant, can be a significant and costly exercise. What we've tended to find with various iterations or layers of attempts to deal with legacy systems is we've actually increased that technical debt. The support infrastructure, the devices, the software, the systems surrounding legacy systems actually contribute to that technical debt. So the opportunity is greater now. By that I mean that these things went through a variety of different evolutions in themselves. So we had extract, transform, and load tools. Some of those are still very useful, some of them perhaps not. And then we had enterprise application integration as a medium for getting information out of a legacy system and making it available to the channel systems. Those evolved into ESBs. We have this concept, if you like, of legacy SOA implementations, which for many are less than a decade old, but fail to offer the same kind of developer experience and the same kind of APIs that we're really looking for in a modern system. Often people build out queuing infrastructure in order to talk to legacy systems that aren't available 24/7. Of course, the web, mobile, and the customers these days are much more 24/7. And increasingly in the last few years, we've seen bots and RPA start to surround legacy systems as well. If the legacy system didn't exist, we wouldn't need the robotic process automation. So we're building out all of these interesting different layers of infrastructure around legacy systems. So for a financial institution, a bank, or an insurer that's been around for some years, that's gone through perhaps multiple mergers and acquisitions, that has multiple legacy systems and has had various attempts to solve or address legacy systems, but never quite replace them, they might find that they have almost like an archaeological layers of software and systems that are sitting on top of these older systems, trying to make them dance, if you like, trying to make them much more agile in this modern world. So really this slide is really pointing out that the technical debt from a legacy system could be greater than the legacy system itself. And the opportunity here for addressing legacy differently it lies in all of those support systems as well as the legacy system itself. So we're really looking for not just reducing cost, not just increasing speed to market with new offerings, new products, new changes for the customers, make their life better, but we're also looking at reducing costs and reducing that technical debt as well. So the ingredients changing legacy modernization. What is it now that's different from even a few years ago that is changing the way that we might address legacy modernization? So we've got two main ingredients here. One's a technological layer, or a new approach of doing things. And then we've got a method row here as well. So I'll go through each of these. I won't go through each of the Harvey balls, and I'm sure that many of you who are watching this would argue about the fill of the Harvey balls. Maybe that's a question you could put in the Q&A. Q&A function here on the webinar, or you could contact Zeev or OpenLegacy or myself, of course, if you disagree. So technologies that are changing legacy modernization. With cloud, we've seen an opportunity here for what does the world look like if it doesn't take 6 months to procure and then have delivered and then install production servers or server infrastructure? What if you could just get the server infrastructure to do, I don't know, testing or something like that, or to have a look at analytics? What if you could just ask for that on demand? And what if you could program that so that you could automatically request it and then put the server back on the shelf, if you like, once you're done with it, so you can get these kind of microtransactions. And really, microservices architectures have come out of that cloud enablement. So microservices architecture says that, well, actually, if it's quick and easy to deploy and get some code, some useful business logic up and running, well, actually, we can automate a lot of that. And we'll come back to that shortly as well. And then open APIs. We talked about that a lot here. And I think the crucial bit from this slide, or the real target, is the switch in understanding, let's put it that way, between early SOA and what we have today, is this observation that actually the API is the thing that is the target. It's not a medium so to allow us to put a new channel on. Actually, the API itself is a thing of value. And that's really something that's started to come out very much more in banking. Insurance is a little behind. But across all of financial services, APIs are starting to catch on as the thing that drives value. And then techniques. There's been a lot of focus, particularly amongst the fintech and the insurtech, around customer-centered design and agile methodologies. So being able to deliver change much more quickly, change that's relevant, actually, much more quickly as well. There's a key point there about relevance of what it is you're delivering and whether it's relevant to the customer. And then DevOps down there at the bottom. Really, this is a nuts and bolts thing. The guys who are putting the bits and the images and the HTML together, this is something that they worry about, but it's absolutely crucial. And we'll talk more about automation in IT and why IT needs to get shown some love and how DevOps achieves that as well. So these are the key ingredients as I see them: cloud, microservices, and open APIs as technologies, but then we've got methodology and then underlying tools that enable us to take advantage of those new technologies as well. So legacy systems and microservices. So here's an interesting diagram, right? So we've got a big fat legacy system there, and then I'm going to add some microservice to it, and then I've got a lighter colored microservice, and then they're going to, all together, they're offering an API that then can be consumed by client A, client B, and client C. And I think for many who are watching this now, they'll be looking at this and going, well, how is that different from just adding another legacy system, or just adding another stovepipe, if you like, another silo? This looks like you're increasing my technical debt over time, which is kind of interesting. And actually, many people, I imagine, watching this will be dealing with an architecture where they've got multiple legacy systems. They already have 3, 4, tens of legacy systems, in some cases probably applications inventories of thousands of applications. And I'm suggesting that we're going to start adding more things in the back end here. What do microservices really give us in terms of advantage over these old legacy systems? So let's dig into that, and let's have a look at the anatomy of a microservice and why I think this is a different beast. So here we have a very complex diagram with some very pretty colors in. What I want to draw your attention to is the gray bit, right? So the gray here is potentially automatically generated code. This is a huge thing. This is the massive difference that cloud has given us, that the cloud-enabled libraries have given us, that DevOps is giving us, and a variety of different technology trends over the last 5 years. And it really has been quite recent as well. So actually, a microservice is a full application stood up on its own server, perhaps, or maybe on a shared server, but it's a full application. But much of it is automatically generated. A lot of the scaffolding and the things that we have to do today in any kind of application that stores data, that does some business logic, that offers an API that can be consumed by other parties, actually a lot of that can be automatically generated all the way through encryption, authorization. We can specify a data model to it, and actually it can do an awful lot of work here. along with the logging, throttling, caching, and making sure that it's in today's web scale world where we get 24/7. We get peaks and massive peaks in activity when we start doing adverts or something happens on Instagram. These things are built or automatically generated so that they can scale. And actually the amount of effort to create a microservice then goes in that small green box in the middle there, the core logic there, which makes them a very interesting and very different beast. In terms of the technical debt, if we're looking at a legacy system where we've built all of this infrastructure and we've hand-coded it and it's written in COBOL or it's written in RPG, very, very difficult. We become very attached to it, right? It's taken a long time to build this thing. There's bits of it we've forgotten how they work, but they feel important and we need to keep hold of them. And that kind of builds us the technical debt, the challenge in recreating it. So the technical debt associated with a microservice is much smaller, right? If I want to generate a new microservice, the vast bulk of it comes to me automatically. Actually, it's automatically generated by the infrastructure I'm using. But the core logic, the logic that sits in there, then is quite small. If I need to re-implement that, or if I need to generate or implement a new API, actually the cost of ditching a microservice and creating a new one is very small. So these things are very, very quick to build because of now, assuming that we have the automation around it, assuming that we're using a modern library that allows us to automatically generate this code, this becomes something that's very, very quick to build and is almost disposable, right? We could almost build something that's very, very useful. Once it exceeds its use, we can close it down. So the cost to get rid of this thing, the technical debt, if you like, is much lower. So if I look at a coexistence architecture, and in the title of the slide, I've written the word simplified, and I'm looking at it thinking there's a lot of dots and lines and boxes on here. But the idea here is then, actually, if I think about an existing financial institution, right? So maybe the participants, so the guys, the fintech that we're trying to work with, are all bringing us interesting microservices. There's lots of them. They've all got nice APIs. And actually, I started to augment my own API by building some microservices here, roughly in the middle at the bottom. But I still have some useful things happening in COBOL. I've got some useful things happening in RPG and VSAM. And those things, they don't offer a RESTful API. They don't offer an API that's easy for a developer to consume. Most developers balk when they see a copybook from a COBOL application. What can I do with those? And so the opportunity here is actually to build out a microservice that handles much of that interaction, offers that API, and then has a way of various mechanisms for interacting with the COBOL application, with the old stores, the old RPG in the background. And actually, the very interesting thing for me about this is this infrastructure doesn't rely then on having an ESB. It doesn't rely then on having all of this other infrastructure that may exist around some of these older applications in order to make them useful and in order to make them relevant to this new world where we've got channel systems trying to consume APIs and offer services to our customers. So that was very, very quick, but a few pointers on the path forward, and then I'll hand over to Zeev, who can will take it over for the rest of the webinar. So first, if you take my assertion and if you take my hypothesis as being appropriate, I am suggesting that legacy can stay. Actually, chunks of the legacy applications that are doing useful things and have worked for many decades are worth saving. But I would argue that automation is non-negotiable. You have to, in order to get the speed, in order to get the ability to change, in order to be able to turn on the sixpence, if you like, which is in order to get that agility, we need to have that automation within IT. We need to be able to automatically generate chunks of this code. We need to be able to automatically deliver parts of our infrastructure. Legacy methods and tools are the things that disable the enterprise, perhaps not the legacy applications themselves. So have a look at how you're delivering these APIs, how you're delivering IT solutions to your customers without, and maybe be less concerned about the underlying technology. So number two, coordination is the enemy of speed. As an architect, as a technologist, as somebody who helps financial institutions think about technology, flexibility is often seen as a really good thing, being able to do something multiple different ways. But actually, if you've got lots of different layers of integration, if you've got lots of mechanisms of trying to get at business logic, at data that resides in a legacy system, if you're spending 2 weeks deciding which route to go, that's 2 weeks that you're not actually delivering anything useful. So enable agility by reducing the layers of integration. Have one route for doing integration. Understand the pros and cons and streamline that. Automate as much as you can around design, around the build, deployment, testing. Many of these things can be automated. And then look at your legacy support systems. Do the same, actually. If they're increasing complexity, if they're increasing the number of questions you have to answer in order to do something useful, then look to streamline that and automate that away. And then finally, you can open new revenue streams without addressing legacy first. So there's an assumption actually within kind of arisen from fintech. It's coming from financial institutions. Actually, we have to address legacy, and then we can do new stuff. Or maybe we have to create an entirely new financial institution so that we can finally be free of the legacy. But actually, I'm finding organizations are delivering new products, repackaging old projects, and engaging new services, living with legacy systems. Actually, they can repackage those and get real value out to their customers. So thank you very much. That's it from me, and I'll hand back to Martin.
Thank you, Craig, for the discussion about legacy systems, the world of API and DevOps. As a reminder, questions can be submitted at any time by clicking the questions icon in the Zoom webinar window. We'll answer your questions after we hear from the next presenter, Zeev Avidan. He's the Chief Product Officer for OpenLegacy, to discuss microservices and show some success stories from the financial industry.
Thanks, Martin.
Yep.
Thanks, Martin. Thanks, Craig. As Marty said, I will be talking a little bit about leveraging legacy with microservices. So I will touch on a lot of the issues that Craig talked about, but kind of more specifically geared toward microservices and how they are actually implemented. And we'll give also some case studies, one or two. But let's start with the challenges. So you're on your way to kind of the digital journey, and you already have some microservices deployed, or you might have APIs already, but then you hit your legacy systems, and that's where things go kind of array. And what are some of the challenges that you might encounter? So first and foremost would be a backlog, meaning you need a lot of different services. You might not actually know how many services you might need, but you start accruing that backlog of services where you need 400, but you only have the first 50, and that kind of continue to grow. So that's challenge number one. Just you're not keeping up with the pace. Another challenge would be scattered technologies. You might have different legacy systems. So, most organizations don't have just one legacy system. They might have different systems, and these systems might be, just different versions of the system, or might be completely different platforms. But they all use different technologies in order to integrate. So that means that you have to support multiple ways of integrating into your kind of digital services and digital frameworks. And that create additional work, additional delays. And of course, if you use traditional methods of integrating, as Craig mentioned, SOA, you increase your technical debt every time you're trying to do something new. These are highly coupled middleware products, and every time you're trying to create a digital service coming from your, for example, mainframe or other legacy systems, that means that you need to add components to that. And these components add to your technical debt, because someday you will need to figure them out, you will need to decouple them, you will need to get rid of them, or do whatever it is that you want to do in order to migrate away from them. But they add to your technical debt, and they add to that kind of sphere of things around that legacy system that keep growing and growing and growing. Speaking of migration, you want to have a migration strategy, or at least a lot of organizations do. A migration strategy is not necessarily kind of the old Big Bang kind of things where you say, well, one day we'll turn the key on a new system and we'll turn off the old legacy system. These kind of projects tended to be challenging, to say the least. But you do need a migration strategy, just because, you know, cost structures might be not what you want them to be. You want to get away from certain limitations in technology for all kinds of reasons. You might want to migrate away from your legacy systems eventually, but do it in a way that's a little bit more kind of evolutionary rather than revolutionary. So a good, robust migration strategy is something that you might want. But if you're, again, adding more digital services, adding more capabilities, basically building and relying on those legacy systems, and increasing your technical debt at that process, that really makes the migration, thinking about the migration even harder to do. And of course, there's the question of DevOps. How does a legacy systems coexist with a DevOps process and pipeline, which is not really geared toward legacy? Now, there's a little bit of a caveat here, because if you think about it, for example, on a mainframe platform, the same concepts of DevOps basically have been as exist for decades now. I mean, things are highly automated and all the pieces fall into place, but that doesn't really play well with everything else. Consider the fact that no real digital service, go through one application. Most services, most business processes go through multiple applications. And that means that you need to align the DevOps part with what you're doing on the legacy side, or at least get a kind of cohesive process to move things on velocity. And last but not least, or to be honest, that's the most important thing for most people and most organizations, that's just time to market. The whole idea of moving to a microservices environment, of going through digital transformation, is about velocity, the ability to change very quickly, to react more rapidly. Time to market is almost for everybody, that's top of mind. You want to be able to create new digital services, do that at pace, and change them quickly in kind of a cycle of feedback and response. This is not necessarily the easiest thing to do if you consider all the other factors here, the technical debt and the middleware products and all the scattered technologies, and the fact that you already have a backlog, and the fact that your processes are not necessarily automated. So time to market is really where you want to go, but that's kind of a challenge in how you get there. So that's a simplification, but not an oversimplification of how a modern organization might look like. So you have your digital channels, and you might have your microservices that are doing all kinds of good work. And that's the innovation part. That's the innovation layer. That's the innovation side of the business. And you move rather quickly there. And that's, using best practices and probably standard technologies. And there's a lot of good stuff there. But when you're actually trying to get to the core data, core processes where your business actually lives, that's where you hit that kind of wall. And that wall is, the legacy systems. But as Fred mentioned, it's not just the legacy systems themselves, it's the ecosystem around them, and more specifically, the integration stack on top of them. So traditionally, what we used to do for the last 2 decades, even more, is do SOA integration, use an ESB, and that was a huge step forward. And those ESBs were kind of huge middlewares in the middle of the organization. Basically, everything went through them. They might have coordinated everything in an asynchronous way or through web services, SOAP interfaces. But basically, these ESBs were the main construct of enterprise integration. These ESBs served their purpose, and they were much better than the point-to-point interactions that we had before that. But you can't really address today's needs with 20-year-old technologies. And that means that ESBs today are quite, to be completely honest, are too slow and too cumbersome for the task. They are not microservices ready. They don't play well with microservices. They are pretty much very much coupled with the layers beneath and even above them. And they by themselves contain a lot of business logic that's got accumulated during the years, which means that every time you're doing something, every time you're trying to get a digital channel, a digital service to work, you need to get there and write some code and do some very complex tailoring and customizing in your ESBs and middlewares in order to get it to work. In addition to that, they might require you to do things on the legacy side, like write facade programs. So if you have a legacy system that has what we call a context layer, meaning you can't just go and run a service, but you need to gather a lot of context information in order to run that service, that means that you need to orchestrate that somewhere, and usually that's being done on the legacy side. So you have the legacy side, you have orchestration. On the ESB side, you have orchestration. And then on top of that, we're trying to introduce another layer of orchestration or choreography, which is the microservices layer. So there's a whole lot of business logics going around all over the place, and that really adds to the complexity of trying to do it in this way. So quite frankly, what you have is a very modern, innovative layer that moves really fast on top of a very slow-moving infrastructure and platforms. And of course, an organization cannot move at two speeds at the same time, meaning your digital service will only be as fast as the slowest link in the chain. That means that you can run into months in order to create a digital service, whereas with microservices, you're talking about really kind of moving at a rapid pace. So what might be a good solution for that? So basically, not to be too blunt about it, but getting rid of that middleware stack, getting rid of the ESB, getting rid of all of those asynchronous protocols and queuing products, and basically have microservices connecting directly with the legacy system. In this case, what you might see is a standard microservice. A microservice has three components to it. It has a lot more, but if you simplify it, it has basically three components to it. It has an API contract. That API can be, a messaging contract, can be a REST JSON API, can be other things. It has an independent microservice, which is basically the business logic and all the cross-cutting concerns, which can be automated. And it has the SDK part. And that SDK, in this case, is basically just a way of connecting with the legacy system instead of an independent data source, just connecting with the legacy system in a direct way. If you do that automatically, and we'll talk about automation in a second, but if you do that automatically, that means that you can do away with all of those complex middleware products, still get your governance, still get everything that you want to get, but instead of doing kind of double the work, meaning orchestrating and governing both on the ESB layer and on the microservices layer, you get rid of the ESB layer and you do all of those things just on the microservice layer. Again, this is not something that automatically happens. This is something that you need to set up. But once you set it up, basically you kind of build a muscle of creating those digital services. In this case, what you might have is basically a way to extend the innovation part, extend the innovation layer, as it were, all the way down to the legacy system. Now, once you go all the way back to the legacy system, the legacy systems are what they are. So keeping in mind that these legacy systems still exist and still do the same thing that they do today, you can extend the innovation all the way on top of them and move very fast. Why is that important? because it gives you a couple of things. First of all, consider the fact that legacy systems are not necessarily that big of a problem if they work, and they do work, otherwise they would not have been legacy systems. So they keep doing what they're doing. On top of them, you have that microservice layer that basically connects them to everything digital. So they play well with others. That's one of the characteristics of legacy systems. They don't play well with others. Now they do. So you can leverage your core businesses, core business processes, core data. You can leverage that in everything else you're doing in the organization. So if you're, for example, an organization that deal with customers, most organizations do, every time you have a touch point with a customer and you're not bringing everything that you know about the customer or could know about that customer, if you're not bringing that to bear at every touch point, you're missing out on something. You're missing out on an opportunity to serve them better. You're missing out on an opportunity to provide them with a new service, or to upsell, or just get them to know you better and interact with you better. If you are able to bring to bear everything you have on your legacy side and really connect it through those microservices in a very quick way, of course, then you can do that. And for this reason, being able to move very fast on that side is important. That's just the connecting part. But if you think about it, now that you have a microservice that talks with that legacy system directly, you also have an opportunity to extend the logic. So extending the logic, extending the functionality on the legacy side might prove difficult. It requires specific skills. It's not necessarily something that you have the capability of doing. But if you extend that functionality on the microservice itself, then you have an opportunity to provide, better customized experience for specific digital channels, or just add additional logic that is not core logic, meaning there's a system of record and all of those records must have specific logic to them. But on top of those records, you might have engagement logic, integration logic, all kinds of different types of logic that are not relevant to the core data. And these are a good opportunity to be basically to host them or to have them on the microservice. So you're able to move faster, you're able to integrate better, and move at velocity. But what does that require? That requires basically automation. When we talk about DevOps and DevOps with microservices, DevOps is always good. Automation is always good. But for microservices, it's absolutely necessary. And the reason for that is that a microservice architecture is not simple. And I know that a lot of times when you see a depiction of a microservice and you think, well, a single microservice is a simple thing. It's basically a simplification of an entire application into just one specific concern or one specific functionality. And dealing with a single microservice is rather simple. That's the entire idea behind cross-functional teams. That's the entire idea behind being able to move at velocity and changing and deploying very quickly. But the architecture at large is not very simple. In fact, it's much more complex than a monolithic architecture. You have a lot more moving parts. These moving parts are separate and decoupled. You need to entertain a lot of different scenarios in terms of disaster recovery, in terms of high availability. So a microservice architecture is a complex architecture. That means that to gain the benefits from microservice architecture, you have to have automation. If you need to think about how you deploy and what are the different servers, that's just too time-consuming and too complex. So you need to be able to automate as many processes as possible. This is how you get to velocity. If you can automate the deployment process, that's one thing. If you can automate the testing and versioning processes, that's another thing. But ultimately, you want to also automate the process of generating those microservices as much as possible. And you have, as Craig mentioned, you have a lot of great frameworks and boilerplates and cross-cutting concerns that can be automated through pretty standard frameworks. But the integration part is also something that you want to automate, because that takes a lot of time and that takes a lot of effort. So you want to automate basically everything with regards to generating those microservices, so you're able to deploy in velocity. And when I say deploy in velocity, I mean, if you consider something like a Facebook, they would deploy 10,000 times to production. I'm not suggesting that a bank should deploy 10,000 times to production a day, which is what Facebook does. And they rely on a concept of recoverability, meaning they don't mind if something bad happens in production as long as they can recover it very quickly and automatically. I am certainly not suggesting that that's something that a bank should do, but deploying multiple times a day, certainly multiple times a week, that's certainly a reality that can be achieved. So how does that all look in reality? I will talk about two use cases, one in general and one more specific, just to speak about the results that can be achieved. So this specific use case is for a bank called Craig Beattie. And the challenge here was around the legacy system. It wasn't even one of those legacy systems that you might naturally associate with legacy. It's not a mainframe. It's not an AS400. These are just stored procedures in a database. But it is a legacy system because A, it's hard to integrate and it doesn't play well with other, and it limits what you can do. And if it limits what you can do, then it's a legacy system. Even something that was brought to production yesterday, if it limits what you can do tomorrow, it's already a legacy system. So in this case, the challenge was really about how to create a way of generating APIs automatically and very, very quickly. So using traditional SOA architecture proved to be somewhat challenging in terms of being able to bring APIs into production very quickly. Moving fast was not really something that was achievable with traditional architectures. And really there was a drive to innovate. But the requirement was that legacy business logic should remain in the system. So just migrating away was not an option. I mean, consider the time, consider the cost, but mostly consider the risk of migrating your core business processes. The risk can be quite daunting. So what they were able to do is basically move from a traditional SOA architecture to a microservices architecture in 3 months, basically moving everything to a Docker container kind of a platform and create a collaborative platform. The results that they saw was in 10 weeks, they were able to deploy 27 microservices and launch a new 360-degree customer review application. I mean, consider the fact that you're able to deploy in 10 weeks, 27 new functionalities or functionality points into production. That enables you to move very quickly. And in this case, 360 customer review, that's one thing that our customers, at least, that's always interesting to them as a kind of a first project, because that really is the baseline of a lot of the other things that you're trying to do. Again, keeping in mind that you need to bring to bear everything you know about the customer in every interaction. So this is kind of a really fundamental bunch of microservices and APIs that they were able to bring to production very quickly. In terms of development time, you would imagine that it will be faster, and it was 65% with 50% less resources. Just consider the level of automation that is now possible that was not possible before. And one of the benefits that you get, and we haven't even talked about it, is performance. Traditional integration stacks usually add a lot of latency. Legacy systems measure a couple of microseconds per transaction. Communication might add some latency, but then comes the middleware part where you have multiple products and multiple leaps, which add hundreds of percents to that latency. We kind of grew accustomed to that being the case. And for a lot of different use cases, that just, that's fine, that works. But today, if you consider all the new channels of engagement with a customer and the fact that you don't really know who uses the API, the consumer of the API might be man or machine. So reducing latency and increasing performance is incredibly important. And in this case, they were able to increase performance by 300% just by using the new architecture. But that is a little bit high level, so let's dig a little bit deeper into another use case. In this case, it is a tier 1 global brand name bank, which we cannot name, but it is a household name. And the challenge for them was really having multiple disparate customized core legacy applications in multiple regions. So that is a bank that grew by acquisitions, that grew, of course, every organization has its own history. And by acquiring all of those different systems and all of those versions of the same system, basically what they ended up with is with kind of a hodgepodge of multiple legacy systems across geographies. And they had a backlog of hundreds of fundamental APIs that they needed in order to deliver their global services or global APIs. So their idea was to create a global API that no matter where you are in what geography looks the same, but it goes to that specific core system or legacy system in order to provide you with that data or process in the same way. And their challenge was around long development cycles. They had an army of developers, over 200 developers, that they needed to do the job. So this is the traditional architecture. And the traditional architecture, you might recognize it is basically SOA-based architecture. And this is what they moved to. A microservices-based architecture with microservices talking directly with legacy systems, all behind a routing mechanism that is Zool, that's on the Netflix stack, and all behind an API gateway. What they're able to achieve is basically get to a legacy microservice API created in 2 days. That's because of the automation. In terms of performance, again, they saw 7 times improvement in performance. So performance, again, it's not something that you think about ahead of time, but it is extremely important. They were able to eliminate the backlog using agile development and using those kind of automation. They significantly lowered the cost of development, and they were also able to add new logic and additional functionality when talking with those legacy systems. So that's it for me, and I'll move it back to Marty.
Thank you, Zeev, for the discussion about microservices and some success stories. There have been some questions coming in, so let's take a look at them and start answering some of them. So how will chatbots change the urgency of connecting with legacy systems? This one is for Craig.
Hi. So chatbots, eh? One of the interesting things about when the web was adopted, we often saw that paper forms formed the API or the means of communicating with the legacy system. So the website became the paper form. It just became a digitized version of that. And we still see that quite a lot around the globe across financial services. But that kind of integration doesn't work for a chatbot. A chatbot needs to be able to have to pass pieces of information at a time, lead somebody through a set of questions, and actually it needs quite a bit of flexibility as well. So being able to query different APIs, being able to query different parts of the application is absolutely crucial to that, and that requires quite a flexible API. Anyone who's used Google Assistant or Alexa or anything like that will probably be familiar with that as well.
Okay, thank you very much. Since we're probably gonna, we may have too many questions to answer, but feel free to text them in anyways, and we'll make sure to tell you to give you answers back afterwards. But we're gonna go on to another question. How do you help with security given we're exposing our legacy systems to new channels? I'll pass this one over to Zeev.
Sure. So yes, security is of course a major concern, and the way you deal with security is basically you have all of those standard ways of doing things. So authentication and using encrypted channels and doing all of those things. So there are standards around that you can leverage, but there are two, I would say, focus areas that I would mention. And that one thing is being able to secure communication between microservices and not just from the gateway to a microservice. That is called in-depth defense, that is extremely important because you don't really know who the consumer of the microservices is going to be and whether or not they're coming from the outside or the inside. So that's one very important thing. And the other very important thing is being able to integrate your new security measures or your new security schemas on the microservice architecture with the old one, which might be, you know, an LDAP or Active Directory or even a legacy one, Rackif on a mainframe. Being able to coordinate those two layers of security is also very important. So there are absolutely ways of doing that. And I would even say that in most cases, for all kinds of historic reasons, you would end up with something that is much more secure than the old SOA implementation that you already have.
Thank you very much. Another question. We aren't ready for DevOps. How does this simplified architecture help with just the CI component of DevOps? I'll pass that over to Craig.
Thank you. Yeah, I was wondering who that was going to go to. So CI is continuous implementation. Continuous integration, sorry. So I think Zeev discussed it quite well, where he's saying that DevOps isn't something that a legacy system typically was built to do. Although if you do go out and search on the web, you probably find some guides to doing DevOps with COBOL and things like that. They are starting to surface now. My suggestion would be, and it's not a direct answer to the question, but my suggestion would be any level of automation that you can do, any opportunity for automation that you can find, take it, grab it with both hands and adopt it. And whether that's continuous integration, so that's the act of, once you've written some code, you automatically test to see whether it integrates with the rest of the infrastructure, or whether that's just simple automated testing, whether that's something around automatically configuring the servers and that sort of thing. Any opportunity you've got to do some kind of automation or improve the level of automation within your IT function is only going to help with the velocity. And if you don't think you can get to the full DevOps style level of automation, doing something is better than nothing.
Thank you very much. The next question I'll pass to Zeev, which is what type of development effort and expertise is required in order to create the microservices? So that's a very good question, and that really depends on exactly how you're set up. If you're set up in a way that everything is automatic and you spend some time and thinking with regards to how you build the infrastructure ahead of time, that means that the actual level of skill that you need in order to create the marginal microservice is very, I would say, available. It might be a Java or a JavaScript kind of a very standard skill set. If you don't do that, if you try to get at it kind of in a very piece-by-piece way without thinking your strategy, without really having a coherent strategy, then you might run into troubles, because then you might have a situation where every developer needs to know their own stack, they need to know unique things, and then you get into some trouble. So I would suggest spending some time on really thinking how you can automate the process. And I know that's a word that we use all the time, but that really is a key word here. If you spend some time thinking about how you can automate the process, how you can bring as many automation tools and practices and techniques that you can, that really saves you a lot of time and effort in the long run, and really kind of standardize the skill set that you need in order to move forward. Okay, thank you very much. And this one I will pass to Craig. I'm with a bank. How will this new architecture help us coexist and even compete with the fintechs?
I think the key thing is so coexist and compete, the competition. I think the key thing here is that the fintechs are typically very, very focused on getting someone to adopt their technology. That might be a customer, in which case they might own a channel to distribution or for getting products out there. And the key then is to give an API that fintech can work with. It might be that they're offering something quite different, or some new technology or some new capability, which would augment your capability, right? It makes your bank better. In which case you need to be in a position where you can consume that API in a way that is modern and digital. So anything you can do in order to start to adopt those technologies absolutely makes sense. If you can and to some degree, I've seen some financial institutions building out their first microservices implementations just to get that API out there in a format that a fintech can use. So I think many of the technologies we're talking about here are really about building out the API, and that's the route to engaging with the fintech community.
Okay, thank you very much. And this one, Zeev, our integration vendor suggests we build the microservices and APIs on top of their ESB SOA middleware. What are the pros and cons of doing that?
The pros and cons for yourself or for the vendor? That's the question. But to be good, that's just kind of a tongue-in-cheek. The pros of doing that over the ESBs or over the existing middleware, I mean, it's there, it's available, you can do it, you know, pretty quickly. It's a quick and dirty solution. That's the pro. That's also the con. It's a quick and dirty solution, meaning it will get you there, you know, kind of in the familiar ways, but very soon you will run into some troubles. And those troubles would be, first of all, in just, if you have, you know, a couple of digital services or, you know, less than 10, okay, that might be sustainable. If you have more than that, if you have hundreds, if you have thousands, or expecting to have thousands, that's not really a way that will support you in that effort. Also, in terms of maintaining those microservices, consider the fact that you will have to maintain both stacks. You will have to maintain both the microservice on top of the ESB, but also everything beneath it, which is, again, as I mentioned, increasing your technical debt. So there, I mean, it's all a question of the specific scenario, whether or not you're thinking about doing it at scale, whether or not you're thinking about being, you know, able to create that muscle of creating those microservices and APIs. If you do, if you think that you might have more, if you think that that's a viable strategy for you going forward, then I would suggest, you know, rethinking that proposition. But if it's just a matter of plugging a hole, you know, that might be good enough.
Okay, thank you much. I think we just we finished up the questions, and I guess we'll finish up the webinar. Thank you for everyone for attending, and hope you enjoyed it. And the recording will be available within 24 hours. Thank you.